Well, hello friends. Welcome back to Commute Talk. Today, the weather is looking gray and like we're gonna get some rain, but who cares? So the snoring one writes in asking about the Doom optimizations that I made, if we're gonna see a video about that. So I realize now that I should have recorded myself making those optimizations, but I'm gonna give you the next best thing, which is that I'll talk about it in the car. So basically, the main reason that the game was running slow while I was porting it was because of the double buffering that Serenity does in the GUI. So the way that works is that whenever you paint into a window using the regular GUI framework, then we maintain two separate bitmaps. So you're always painting into the back bitmap while the front bitmap is shown on screen. And then when you're finished with one round of painting, or whatever you want to call it, then we swap their places. And now the back bitmap is what you see on screen, and the front bitmap becomes the back bitmap. So this is a pretty typical double buffering setup. And because it's all software rendering, that means that buffer flipping, like switching between the buffers, is essentially like a lot of mem copying. Because when you flip the buffers, when you like tell the Windows server, hey, now make this buffer be the backing store of this window, then what it has to do is actually just mem copy everything from the new buffer into the screen memory. And not only that, but the thing that, like, when you're switching the places of the back and front buffer, then in order for partial updates to work, so like if you do a partial repaint after a repaint, then we have to make sure that the buffers are in sync. So when you flip the buffers, we also have to copy over whatever we changed in the new front buffer to the new back buffer, if that makes sense. Maybe there are probably some better techniques that I could use here to optimize this. So if you know of something obvious that would be a good improvement, I'm very interested. But anyway, so basically, for every frame rendered in Doom, we would do a lot of these buffer copies back and forth, just because the reason that we do double buffering in the Serenity GUI framework is to prevent screen tearing and like these inconsistent updates, where I guess like a very typical one is that you resize the window, and while it's like in the process of repainting itself at the new size, the Windows server comes in and says, "Oh ho ho, time to paint," and he just paints like an unfinished window that's in the process of being repainted, and that just looks like ass 99% of the time, and you don't want that. So that's why we do double buffering. And you can skip doing it, and then you get artifacts while you're resizing, and artifacts at other times as well. You'll save memory, because double buffering costs one extra back buffer per window, obviously, so it is expensive. But in my opinion, it's worth it if it makes things look better. And there are techniques that you can use to make the memory impact of such a technique less painful by, you can do stuff like discarding buffers for windows that haven't been using them for a while. Like if you have a window that just sits idly, even minimized perhaps, then it doesn't need to have its backing store in memory perhaps. And of course there are more sophisticated techniques like purgeable memory and marking it volatile and stuff like that, like OS X or OS X, like Mac OS does, or OS 10. Wow, I said OS X. I guess I really don't work at Apple anymore. But yeah, so what I did for Doom to make this go fast was just to turn off double buffering, because there is such an option in Serenity that you can say, like, don't do double buffering for this window. And then you run the risk of tearing and inconsistent updates, but you also skip over all of that extra copying. So now you're just rendering. You're rendering once into your window back buffer in the client program, in the Doom program, and then the Windows server copies that buffer to the screen memory, basically. So you have those two copies. So that's a lot less painful than the 4 copies that we had before. And then the other thing that I did was, so the game was set up to render a 640 by 400 bitmap, and it was doing upscaling in the game, or like in the not necessarily in the game, not like in the original game, but in the port of the game that I started with. It was based on a port, which was based on a port, which was possibly even that based on a port. So there was this manual upscaling part where we took the game, which was actually rendered in 320 by 200, and then we 2x'd it up to 640 by 400. And that produced a game bitmap with 4 times as many pixels as we actually needed. So I tweaked the game to not do the upscaling internally, but instead give me a 320 by 200 bitmap, and then I have this optimized function called like draw scale bitmap that is optimized for integer scale factors. So it does this nice inline loops and stuff. It could be optimized way better, but it's already significantly faster than the generic version of it. So that gave me a big improvement as well, because that meant that I was no longer like copying a 640 by 400 bitmap from the game to the GUI framework in Serenity, but we were copying a 320 by 200 one, and then splitting that with a scale factor. And so I guess those were the 2 main optimizations. So like shrink down the game so that we move less memory around, and then also turn off double buffering so we move less memory around. And there's still a lot of stuff that can be done. So there's at least one completely unnecessary buffer copy that can be avoided. It's just the coordination is a little bit weird, so we have to have a way to remember that bitmap, because it's about to be overwritten before we can make use of it. So I have to come up with some way to do that. And then there's also stuff like right now we get the 320 by 200 bitmap in the client app, and then we scale it up in the client and then send that, and then the Windows server paints the upscaled thing. But instead what we could do is that we could have the application render 320 by 200 into the window, and then we could tell the Windows server, hey, this window has a scale factor, and whatever the Windows contents are, they would be rendered at, say, 2x. And then you would get rid of all that extra memcopy work, because you could do scaling on the fly in the Windows server instead. So that would further reduce like all the memcopy thrashing. So yeah, there's still a bunch of things that can be done, and probably some other things as well that I didn't really notice yet. But I guess I just wanted to talk about what I found so far. But memcopy is definitely the source of slowness in the Doom port so far. And there's still more memcopying going on than there should be. So reducing that is definitely going to improve the game. And then, of course, also, there's no audio support, which to me actually happens to feel very authentic, because the first time I played Doom, I didn't have a sound card. So that's sort of how I remember the game being. Quiet. But of course I've played it with sound since many times, and I love the music and sounds and everything. But that original Doom feeling for me is silent. And that's just because in the 90s when I was, well, in the 80s and 90s, when I was exposed to computers early on, it was always because my parents managed to like sneak home some hardware from work, and it would be like my father had like a work laptop that he could bring home to do some word processing and DOS, or my mom was some Excel wizard doing that stuff. But they were always like office computers, and then they never had sound cards or CD-ROM units. So I grew up like on these office computers, which is probably why Serenity looks like an office operating system from the 90s, because for me that's where I come from. I just love that whole feel and look and feel. It wasn't until I think I was maybe 14 or 15 the first time I had access to a computer with sound. And even then, it was my mom's work computer that ran Windows NT4 and could not play basically any games because it had the NT kernel, and most games back then, they did something or other that required DOS because they wanted to do some wacky hardware access. So I don't know what they were doing, but they didn't run on NT kernel, at least. But Winamp ran. So I could listen to cool MP3s, and over time, some games began working on NT4, and I think Doom 95 worked actually. So I got that at some point. Anyways, getting a little off track here, but but yeah. So the game Doom, the game now, and Serenity is basically playable. There's a bit of input lag, for sure, and some of the graphical like effects, like if you pick up an item and the screen flashes, or you get if you like go too close to one of those toxic barrels and you shoot it so that it explodes, then the whole screen goes red, and that's kind of slow. But I think that all of these types of things, it's just a bunch of unnecessary mem copying that we can do less of. So I have to look at those and figure out what's going on. But yeah, so this, unfortunately, I didn't record myself working on it, but hopefully me telling you about it was at least somewhat informative. So that's the status of that. So I guess I'm gonna keep trying to improve on the port a little bit, and I would like to do audio support as well. Although the port that I started on, it doesn't have any like obvious audio support place to put audio support. So in order to do that, we might have to either implement something pretty bare, which might be okay, or possibly switch to a different port, like one that's based on the SDL, and then we could port SDL mixer to get SDL audio support, because I suspect that porting SDL sound support would just open up so many other games for easy-ish porting, because we have SDL graphics, but we don't have SDL audio. And I should probably work on the audio stuff as well in Serenity, because it's still very, very primitive. Anyways, lots of things to do, and that's nice. So I guess I'm out of things to say about this. So I'm just gonna say thanks for hanging out with me on the commute, and I will see you next time.